Let's see another example in which the only obstacle is that the divisor is not 1. All right, let us now use this example number D to learn how to make divisor become 1. Don't forget that making divisor become 1 is one of the skills we said that we shall need in solving equations. By extension, we are going to learn how to clear fractions from equations. Look at this example here, example D. X over 15 is equal to 2 over 3. Anyway, we could as well call this thing fractional equation. It does not mean that each time we say something over something that it is equal to a fraction. The best way to refer to each of these sections is a kind of a division, because even sometimes we refer to fractions as division. Take for instance, 1 over 5, even though a fraction, could also be taken as 5 dividing 1. Therefore, that 5, instead of being called a denominator, could also be called a divisor. Now look at this. X over 15 is equal to 2 over 3. What is the obstacle here? The obstacle is that the divisor is not 1. Look at the divisor. To this x, 15 is the divisor. It is 1 that is supposed to be here to make this x possess all the qualities it should possess. It has other qualities it should have, except that the divisor is not 1. So the trouble lies with this 15. It is also true that this right-hand side contains a divisor, which is not 1 also. It is 3. Therefore, put together, we have the divisors on left-hand side and right-hand side, both of which are not 1. So we want to make sure that x will have 1 as its divisor. If this x has 1 here as its divisor, then we should not bother about this 3 not being a divisor, not being equal to 1, because it is not this 3 we are fighting. Instead, it is this 15. This 3 is going to take part in making 15 go away, but you see, our major focus is that this 15 should turn to 1, since 1 must be a divisor. Now, what if we want to make that divisor become 1? What must we do? Please listen. To make a divisor become 1 in an equation, multiply both sides by the LCM of the divisors, or multiply both sides by the LCM. In fact, not just LCM, any CM can serve. Any common multiple of the divisors can serve. Therefore, if I say LCM, it is just the most workable, because it is the simplest of all the common multiples. Therefore, generally speaking, to clear divisors and make them become 1 in an equation, what we should do is to multiply each term in that equation by the LCM or any other CM of the divisors. Here, 15 is a divisor and 3 is also a divisor. What we should do is to look for the LCM of 15 and 3, or any other CM of 15 and 3. If we are looking for the LCM, 15 can serve, because 15 is the LCM of 15 and 3. If we are looking for any other common multiple, 30 and 45 and 75 can all serve. Why? Because they are all common multiples to 15 and 3. But for convenience, we prefer using the lowest common multiple. So here, we're going to use 15 as the LCM of 15 and 3. Therefore, this term, x over 15, is going to be multiplied by 15. And this term on the right-hand side is also going to be multiplied by the same 15. Don't forget that x over 15 is a term, and 2 over 3 is also a term. If you have forgotten what a term is, please make reference, go back to the topic we had earlier when I was talking about basics of algebra. Now, back to what we're saying here. Look at this next line here. This next line is now carrying out the instruction, which is multiply the left-hand side, which is this term, by this 15, which is the LCM. Do the same thing to right-hand side. Look at this one. 15 times this is equal to 15 times this one too. I hope you are following what is happening here. By doing this, we have it that both sides are now multiplied by the CM of the divisors. That CM is 15 here. All right. We have to clarify the operations here. This 15 bracket x over 15 is the same thing as saying 15 over 1 times, because we have learned earlier that that is a sign between this number and the bracket. That sign is a sign of multiplication, but not shown. Now it is shown here for clarification. So this is 15 over 1. Then times is here. See the times here. Then x over 15. See it this place. So this is what this whole thing here means. And at the same time, this is what the whole of this thing means. Therefore, we now apply the principles of multiplying fractions in simplifying each of the sides of this equation. 15 times x is 15x. 1 times 15 is 15. Here, 15 times 2 is equal to 30. 1 times 3 is 3. That way, we now have it that using associative law, we simplify this to become x and this one to become 10. As a result, x is equal to 10. In this case, x is equal to 10 is expression of solution. And don't forget that what really happened here is in this line IV, is that both sides were simplified. And at this point in time, we are sure that we have used this example to show how we can clear our fractions from equations, or how we can make divisors which are not 1 become 1. Later, we shall see that what we have done here is going to lead to an alternative. An alternative. What is that? Please watch this. It can be shown that if we learn how to clear fractions from equations, simple equations, that we can make the process shorter. Experiment shows that if an equation contains a fraction like this one, and the equation is simple, then that we can use another method, which is an offshoot of this method of multiplying both sides by the LCM of the denominators. What that method is called cross multiplication. Cross multiplication simply means that if you want to clear fraction from an equation, and that equation is a simple equation like this one here, all you should do is to say this times this is equal to this times this. And with that, what you're going to get is another equation that you're going to solve further. So cross multiplication is the faster way of clearing fractions from equations, but it is not independent of this method we just used here. It is this method we used here that produced the method of cross multiplication. I also want to inform you that cross multiplication has its own limitations. There are cases that you should not apply cross multiplication. This is based on experience. What cases are those cases in which you shouldn't apply cross multiplication? It is cases of algebraic equations in which we have more than one divisor on either sides of the equation. Here we have 15 alone as the divisor in the left-hand side and have 3 alone as the divisor on the right-hand side. This kind of equation that possesses one divisor each at both sides is called simple algebraic equation. But if there are 2 or more divisors on any of the 2 sides or both sides, that is where we are not supposed to apply cross multiplication. If we apply that, we are going to get the answers wrong. So be very careful that after you learn to cross multiply by saying 3x is equal to 30, in which case you solve further to get the value of x, which is x is equal to 10, that you do not apply it to any other fraction in an equation that is not simple. That is to say, equation that contains more than 2 divisors on either side or both sides of the equation. Please find the same question being solved by means of cross multiplication, that alternative method I said earlier. We say 3 times x is equal to 15 times 2, giving rise to 3x is equal to 15 times 2, that is this 30. This way, there is no longer any fraction in that equation. It means that either way or both sides, we now have the divisor as 1, and that was achieved by cross multiplication, as we find in the corresponding comment. Now next is that we tackle this equation as before. That is, it still has 3 as its coefficient. The x still has 3 as its coefficient. And so as before, we make 3 become 1 because 1 should be its coefficient, giving rise to, with if 3 divides both sides, x is equal to 10. The answer we got after using this method is the answer we got earlier. So either way, either by using the LCM of the divisors to multiply each term in the equation, or by cross multiplication, we're going to get the correct answer if correctly applied. But don't forget the danger of cross multiplication. Don't apply it if the equation that contains fraction is not simple. That is, if it does not contain one divisor each on both sides of the equation. Now check out the following questions. Right, it says using cross multiplication or CM method, clear fraction or division from the following equations. A, y over 4 is equal to 15 over 20. 3 over c is equal to 12 over 28. In this second example, you should find the LCM of c and 28. Use it to multiply both sides. You're going to get the same thing. Whether the unknown is above or below, the principle is the same. The method is the same. Either cross multiply, as in these simple cases, or find the LCM of the denominators or the divisors and multiply each term in the equation by such LCM. That way, you will end up clearing the fractions or divisions from these equations. Let's move on, please, to the next example.